Thank you all for tuning into the Innovator's Playbook podcast. I'm your host, Seth Narayanan, founder and CEO of Telient Systems. Today on the Innovator's Playbook, I'm joined by Zane Ball, CTO at the Open Compute Project, where he helps shape the future of open, scalable AI and data center infrastructure. Before OCP, Zane spent decades at the Intel Corporation in several leadership roles across hardware design, desktop, and data center businesses, and has led large global engineering teams. Zane holds a PhD in electrical engineering from Rice University and now leads a portfolio career advising cutting-edge tech companies. So, Zane, thank you for joining me today.
Great to be here. Thanks for inviting me, Seth.
Absolutely. Zane, I was impressed looking at your career. I think the PhD in electrical engineering really got my attention. I have a degree in electrical engineering, but never worked a day as an electrical engineer. But you not only completed your bachelor's, but you got your master's and PhD, and then continued to work at Intel, which is one of the pioneering organizations that everybody thinks of in the space of electrical engineering. So tell me and the viewers a little bit about what got you started in your career journey. Why did you choose to be a electrical engineer and then a career in Intel? Maybe paint a picture for how you got to where you are today.
Sure. Growing up, I was always kind of a nerdy kid. And I guess I was always trying to prove that I was good enough because I was smart enough. And my father was an engineer. I was good in math and science, but also good at English and history, and all those things were an interest. I was lucky enough to get accepted into Rice University as an undergraduate, which is a great school for both being very technical, but also having the full complement of humanities and whatnot. I took full advantage of that as an undergraduate. In the end, after looking at physics, I was strongly interested in physics, but I didn't really see much of a future as a physicist because physicists, I think you had to be quite a bit smarter than I thought I was. In the end, I settled into engineering physics, which was part of electrical engineering. Some universities, I would say it's applied physics, but it was effectively a lot of lasers, material science, but the physical layer, I wasn't so much into computer science. I wasn't so much into signals and systems and that kind of thing. So I focused on the lasers and the physics because I thought it was really cool. And it gave me an opportunity to really stretch myself. When I finished my undergraduate, I just felt like I wanted to achieve more academically. I think I still kind of held out the idea of maybe I do want to be like an academic. I applied for and I got a National Science Foundation fellowship, which is a fantastic program. I would recommend undergraduates anywhere. If you can get one of those, it's a great thing. Most graduate students in engineering, you're paid for by some research grant that your professor has. So in a sense, you're very beholden to them, right? And it can be fun. Also be a little bit difficult. But I brought my own money because I had this fellowship that was independent of the professor. So the professor was like, this guy's free. Right? I got into Cornell Graduate School, which is a famous program for nanofabrication. And I was interested in that. At first I applied, I got rejected because they only took 30 students. I didn't make the mark. But then after I got my National Science Foundation fellowship, they called me up and they're like, we'd like to invite you to come to our lab. We'll fly you up. And I was like, what do you mean? You guys already rejected me. And they're like, no, listen to that. So I was offended by that. And I was like, well, I'm not going to want me or whatever. But anyways, I stayed at Rice. I already had been doing research for a professor as an undergraduate, and I was able to plow through the PhD program in just 4 years. I was able to also spend some time doing research at partner labs in Germany and in Hungary. So I got to see a little bit of the world. I'd never been overseas before. And I was excited about it. But after I finally finished the PhD, I was kind of ready to make some money. At the time, it was really good for Intel. This was 1996. Intel was growing like crazy. They overwhelmed us with interview slots and everything at the university. So I got a job offer as a rotation engineer. So I wasn't even pinned down to a particular thing. I joined Intel at their facility in Arizona, and I did different things, including manufacturing and high-speed electrical design. My background was actually excimer lasers and excimer laser polymer interactions. Excimer laser lithography was becoming a thing right then in the semiconductor industry. And I never touched a fab. I never touched lithography. I never touched the things that I was qualified to do. Instead, I ended up getting into signal integrity, which is electromagnetics. And my background in physics was appropriate, but it wasn't like I'd studied that. The world needed people with electromagnetics, and signal integrity was a big thing. And it was like black magic and nobody understood anything about it. I was way above average qualified for that. And so I just kind of jumped into that world, took a permanent job at Intel in Hillsboro, Oregon, which is primarily where I worked. There was tons of work to do in power integrity, delivering power to the chip was also becoming a very electromagnetic problem.
Yeah.
And after a couple of years, I'm managing the team. And then I was managing a bigger team, and that included thermal mechanical problems. I had a thermal mechanical team. We hired all these geniuses from Boeing in Washington State to design heat sinks and mechanical retentions, which could be really complicated problems, solder joint reliability, all these, sure, there's tons of engineering involved in things that are outside the actual chip itself, which is where I ended up specializing. I did that for a number of years. And eventually I got a little bored with it. And this is one of the great things about Intel Corporation. Anybody can apply for any job. And it was a big place. So there's a lot of mobility. And I actually took a marketing job as director of marketing for desktop PC microprocessors.
Okay. Wow.
My boss was the big shot of the whole business, and he and I had a good relationship. He was willing to give me a chance to get out of engineering and into the marketing side. So I did marketing. And for 6 years.
Was that during the Pentium days?
No, it was during the Pentium 4 Intel Core 2 Quad kind of era, for those who remember.
Okay.
So 2007 was when I joined that, and I loved marketing.
I remember those days. I remember my first computer that I got was 386SX, I think was the chip. And then 486, and then the Pentium, and then I forget, you had so many other models.
Yeah, Pentium 3, Pentium 4 to the Core branding.
Yeah. And that's cool. Yeah, sorry, I interrupted you. Go ahead. Yeah, so you got a marketing job.
I got a marketing job, and I started talking to customers. I learned about everything. I was like a kid in a candy store. I'm sort of a curiosity-driven person anyway. I'm talking to executives at Best Buy and how shelf space works and how branding works. I was very data-driven. I'm a nerdy engineer. I'm looking at all the sales data by price point, by brand designation, we would play with the price positioning and look at the response in the market. We'd sort of developed a theory about how the desktop market worked, desktop PC market. And this was in 2009, laptops overtook desktops.
Yeah.
A lot of people, desktops would just sort of go to zero. Everything would be a laptop. The market had been very commodity driven, and it became the commodity market. The standard PC became the laptop. And people bought desktops for very particular reasons. And we kind of unlocked that. And it was exciting market. Some people are bored by marketing, but I love marketing. And we figured out that like gamers and overclockers and enthusiasts were a big market. So we developed the product line, the overclocking product line for that market. Wow. Huge success. We realized that businesses would keep buying desktops in terms of banking, financial services, because they can't afford the hard drive leaving the building.
Yeah.
Traders want 4 monitors, and we're like, oh, let's go work with customers and build a special set of devices for that market. And then we had a whole thing on emerging markets because they didn't have the money in rural India to have a computer for every family member. So a laptop was the answer, but a family desktop, if the price was low enough, was an entry point. We figured that market out. So we figured out little niche markets. We called them niche markets. They were actually pretty big. And we ended up like growing the profitability of the business, even as the volume and the growth all shifted to laptops. We made desktop a star business, and it was a great experience. But I did that to a point that our work is done. I felt like we kind of mastered desktop. This is by 2012. And I had this chance to move to Taiwan. Most people in your audience probably know almost all laptops are made by 6 Taiwanese companies. A lot of the factories are in China or wherever. Now there's more Chinese manufacturers than there were back then. Companies like Quanta, Inventec, Con, these make all the computers. And it's mostly still true today, right? Yeah. And that was when we were building ultra thin and light laptops with touch screens, with long battery life. Intel at the time, we made huge investments in the partners, and I'm helping that Taiwan ecosystem learn to build and make very cost effective. So we built a thing called Ultrabooks. They're really expensive. They're kind of like a MacBook Air and these kind of premium systems, very thin, and figured out with the ecosystem how to make that very affordable to deliver those kind of things. So that was exciting. I learned about Taiwan. I love Taiwan. I learned how the whole ecosystem worked. And when that expat was over, I moved back to the US, and I shifted gears entirely to running Intel's Silicon Foundry business, which was a new business at Intel, very challenging, but learning how to be a contract manufacturer for other semiconductor companies, really tough business. Didn't go so well, but learned tons, right? And made lots of relationships. And then in 2018, shifted gears again and joined data center and moved back to the engineering. So data center, I'm running customer engineering, systems design, motherboard design, packaging design, signal integrity, electromagnetics, developing standards like CXL we developed in my time there, UCIe, DDR5, and developing a whole new class of platforms. That was a fantastic experience. And I really got deep on data centers. We have close relationships with everybody, Dell, HP, but also just as much Amazon, Google, Alibaba, Tencent, all those main players that are doing servers in high volume, very deep relationships with them. This was the height of the cloud computing era. Now we've really pivoted hard into this AI era, which is a very different thing. I left Intel, retired from Intel just as the AI era was getting its acceleration in 2024. And now that's everything. It's the industry pivoting so aggressively to AI solutions, and it's really completely remaking the data center. And that's exciting. I'm so glad I made that change in my career to do data center, because now the data center world is just so exciting on every front. And I couldn't be more delighted. That's my journey. That's kind of how I got here. So after retiring from Intel, I joined the Open Compute Project, and it's been a great opportunity to stay engaged with the industry, working closely with all the key companies from hyperscalers to chip makers to equipment manufacturers, and getting involved in the electric power grid challenges with AI build out, and just learning a lot and hopefully having a chance to really make a difference.
Yeah. So in OCP, you're dealing with, it's kind of a consortium of hardware and data center vendors to that industry. Is that the right way to put it?
Yeah. The history of OCP, it was kind of initiated by Facebook back about 15 years ago. And in the 2000s, the big hyperscale companies, most famously Google, but also the others, it realized that buying servers from HP, Dell, and IBM, they're getting stuff they didn't want, fancy chassis, blinking lights, and it's expensive. And they're like, we don't really need this. We can just design our own servers. At first, it was they're just trying to save a little money, but over time, they realized actually we can really optimize the operation of our large scale cloud services by really dialing the hardware into what we need. And they work directly with the Taiwanese companies manufacturing it. After a while, they're like, why are we spending so much on R&D? Why aren't we all working together? We don't differentiate on these designs. That's not how Facebook makes money or how Google makes money. So they're like, hey, why don't we just open source it? We do open source software. Why don't we do open source hardware? They really brought a software mindset to hardware through the Open Compute Project, a nonprofit foundation, a little bit like the Linux Foundation. People started open sourcing their server designs. And it started with just opening it up so others people could copy it. Then it started into an open source community that really collaborates. And it brings the supply chain into alignment. It brings costs down. It brings more players into the ecosystem and brings more competition. That has been a big success. It's grown from a handful of companies to now more than 500 members. Our conference in October, we had 11,000 attendees. When it first started, maybe you'd be lucky to get 500 attendees. This is kind of how the industry does business. Now, some of those companies that were disrupted by it are big contributors, Dell, HP, and Lenovo, but certainly the Taiwanese companies, but also all, equipment manufacturers of all kinds. And Unity has very low overhead. So it's very easy for companies to come together under the OCP umbrella and work together on different projects. It's all over the place. There's all kinds of little innovations like liquid cooling connectors or filters for liquid cooling. Turns out to be a big deal. It's just a great, easy to work with foundation that lets the community come together and work on problems of mutual interest and add value in an open mindset. A lot of the standards that come out of OCP are a little bit looser than maybe an 802.11 IEEE standard, where you've got to be incredibly precise to have interoperability. You can be a little looser in terms of compliance and validation. Some of them can be just informal standards or best practices, but it's still collaboration that yields good results for the members.
Yeah, I'm guessing it probably also allows them to be somewhat unique and differentiate themselves, because you don't want all the cloud providers, for example, having to commit their designs, or whatever differentiates them still needs to be their proprietary secret sauce.
For sure. I think a lot of the infrastructure pieces are just not that differentiating. So people are willing to be a little more open and lets the ecosystem grow up. But what's a commodity for one company in the ecosystem might be differentiation for another, right? So not everybody's going to see it the same way, but OCP is just a simple, fair framework where companies can come together to collaborate. There's no arm twisting involved. It's just an opportunity, grassroots kind of way of people coming together and organizing themselves.
Yeah, it's good to see that. Good to see that level of cooperation. And I'm sure that sort of fosters better technology in the end for everybody, which is great. Now, going back to your work in a large company like Intel, how does innovation happen in a large environment like that? Because in the topic of our conversation or my podcast is the Innovator's Playbook. So I'm always very intrigued. I know how startups originate and how innovation happens, but in a larger setting, you work with all these other large companies, part of OCP. How do they promote innovation inside and let it foster instead of being squelched?
Yeah, I think innovation in a smart, large enterprise is going to be very thoughtful about how it creates an environment for innovation. Innovation is a big word. There's a lot of different kinds of innovation. I was strongly influenced by my philosophy around it from a guy named Herman DeHooge, who led the Intel Toy Lab in the early 2000s. They developed all kinds of cool products like the Intel Create and Share camera back, the Intel microscope, the Intel MP3 player, which was a big seller until the iPod came out, by the way. They had a lot of amazing thoughts about it. And what Herman taught me was that innovation is really the intersection of three things. It's kind of a consumer products mindset, but you can adapt it. There's technology,
Yep.
there's users, which in B2B, we might say product market fit. You've got to be accomplishing something that the user finds valuable. You've got a technology that can actually make that happen. And then the third pillar is it's got to be economic. There's got to be a business model. The simple product level could just be that we can make this for cheaper than the user's willing to pay. But you can imagine being a little bit different. A good example of that might be to think of like YouTube. Really cool idea when it came out. Tremendous product market fit, right? It just went viral. People loved it. And it just happened at the moment when technology and the internet and bandwidth and computers were fast enough, the bandwidth was high enough that you could actually deliver this YouTube experience. But it was a disaster when it came to business, right? It was radically too expensive to do. And there was really no way to make any money out of it. So when Google bought YouTube, they made a bet that said, I'm really good at infrastructure. I bet I can bring the cost of this way down. And I have a great business model in terms of ads. I bet I could figure out a way to make money doing this. And I could find a way to bring the cost way down.
Yeah.
It took forever, but they did. It took years, because you've got to master all three.
Yeah.
Now, if I'm a big company, I obviously have any core business where I already have mastered all three. Think of like Intel in the PC era, right? I got technology to make chips. I've got a use case that I know makes sense in terms of a basic laptop or whatever. I know people need laptops. I know what they do with them. I might evolve that user experience over time, and I've got a business model that works. So you've kind of got all three. Now, when you're going to change something, if you change all three at once, that effectively means I'm creating a new business from whole cloth. It's going to be quite risky. I think it's very hard for a large enterprise to have a blank sheet of paper business. Why not? Startups are way better at starting with something without the baggage, right, of the bigger company. But what if I've had a business opportunity that borrows the technology I already have? Maybe it borrows the business model that I already have. You could imagine that was kind of the Google YouTube case, but it's got a new user, new use case, new product market fit. Well, now that risk is much lower. I've got a good reason to attack that, but I need to innovate that new product market fit. Or maybe it's just, I'm going to keep my business model the same. I'm going to keep the user experience product market fit the same, but the technology around it, I'm going to compete on. So that's Intel. Every 2 years, Moore's law turns the crank. I know what I need to do, right? Necessity is the mother of invention. I can, with utter confidence, and I can be persistent, and I can spend a lot of money, and I can have a long-term investment. I can take risks on new technologies and ideas. In the last 50 years, we have high-K metal gate, you have things that, you have novel technologies that cost an extraordinary amount. You think about semiconductor providers, like an Intel, I'm going to dig a hole in the ground. I'm going to spend $20 billion building a factory on technology that doesn't exist yet for products I haven't designed for markets that I don't know what they are. That's kind of the mindset, right? But since you know that you have this position, you're willing to take that kind of risk. And advancing semiconductor technology is very risky and it's very expensive. But if you have a good business model, those use cases are there, then you can do it with confidence. So that's kind of how I think about it. Now, if I want as a large business to enter new businesses, I want to escape my core business and I want to open myself up to new things. You really have to think through how you do it in a disciplined way. One of those ways is to have a whole spectrum of innovation tools in your toolkit. One of them is evolve my core business. So that's the one we just talked to. Another one could be I have a venture capital arm. I'm not going to enter this business. I'm going to invest in the business. A lot of these big companies have it. Like Intel had Intel Capital, but not even been one of the very first ones. Most of the companies have some sort of venture side, and they can invest and gain exposure and opportunity to emerging things. In 1998 or something, your Intel, I want cable modems to exist. I don't have to build cable modems, though Intel did pioneer a lot of cable modem technology. But cable modem companies, I'll invest in them because I know if cable modems become successful, internet bandwidth will be helpful to my business and I can win-win. So the venture arm is like, what about things in between? What about something that's kind of adjacent to my core business, but I don't want to bog it down with all the potentially incorrect incentives. What's good for the new business might be bad for the old business. I don't want to force them to use a particular technology set that just happens to be the thing I'm good at, kind of the hammer nail problem. So you can actually do collaborations with startups and you can have a bullpen of startups that are working on closely adjacent things. And then the startup can take advantage of maybe your sales channel, or maybe the startup can take advantage of your technology support, or maybe the startup can take advantage of your customer relationship. So you can create productive partnerships as you explore these new ideas where you're trying to find. And so it's a little bit more directed than just investing money and hoping for the best of VC. It's saying, hey, I can participate, I can contribute, but you have to do it. You have to be super careful about it. And then the third thing you can do is just invest in radical new businesses inside your company. Then you're effectively doing startup work inside your company. Now, the difficulty with this is it's an area where I think most companies fail. There's so many reasons why it's wrong to attach a startup value proposition to a mature enterprise. Because the incentives for what the startup needs might be disrupting the core business. So there's going to be a natural tension. There's going to be the fact that you entering that new business puts you in competition with other companies that might be your customers or your future customers. That can be a problem. And if it's a new area, like let's say it's quantum computing or something, there's a lot of experiments that need to be run on a lot of different ways of building a quantum computer. Who knows which one's going to win? But by entering the business yourself, you're picking a winner.
Yeah.
You're going to become incredibly biased around the success of your quantum. I'm just using quantum as an example of your quantum computing startup within your company. Who's the biggest expert on quantum computing? The one that's running your startup, who's incredibly biased. So what if they fail and you miss the quantum computing revolution because you were obsessed with this one approach? There are actually 10 approaches or maybe 100 approaches out there, and you put all your eggs in this one basket, you might make mistakes that way. It's very hard to just tackle something from whole cloth within your company because sometimes you're just not the right company to do it. You don't have the right skill set. You don't have the right market presence. You don't have the right ecosystem position to be the winner. An example, back in the early 2000s, we had a technology opportunity where mobile technology, cellular technology, was advancing and starting to carry data. You had Moore's law making microprocessors power efficient enough to make them handheld. And a lot of people saw that opportunity. Now, we all know today that we have the iPhone and the smart, we all know who won. But it wasn't as obvious then. When the first BlackBerries came out, they actually had Intel chips in them, by the way. That was an emerging thing. And people, all the human factors work was done. I've seen a lot of companies had the vision of the iPhone. A lot of companies did. But if you're from the PC industry, whether that was Microsoft or Intel or Dell or one of these companies, they were trying to make the iPhone like a PC, horizontal ecosystem, pulling software and hardware apart, right? That's how PCs work. We had different companies making different pieces of it and putting it together. It turned out to make a really good phone experience. It's far more integrated than a PC experience. You really needed one company to integrate everything together very flawlessly. That's what Apple was the world's best at. But it wasn't because nobody else thought it up. Concept videos from all kinds of companies about the convergence of cellular and compute would happen. And all the use cases that the iPhone made happen, everybody saw it, not everybody, but many companies saw that coming. Many invested in it. But it turned out you needed to be the right company with the right skill set, the right brand. It turned out things that Apple had learned in iPod, things they learned with iTunes, their aggressive focus on hardware software integration yielded a beautiful product. They won in the biggest possible way. The iPhone was going to happen. The question was who was going to figure it out? Who was going to capitalize? And clearly Apple delivered the goods and won the big prize.
Yeah. We talk about Apple and Intel that you worked at and all these large companies. Research suggests that companies have a kind of a definite lifespan, right? They start up, they rise, and then they dominate for a long time and then eventually die off. Do you think that's true, or are there ways that companies can renew themselves, maybe through the startup ecosystem, or maybe using intelligent M&A, getting into new markets and new technologies that are not core to them? So what are your thoughts on that?
The research is pretty undeniable. You can look at the statistics. There's a great book called Scale by physicist Jeffrey West. He looks at all these scaling laws of all kinds of different areas, but companies is one chapter.
I'll have to read that.
The statistic is quite amazing on that it's a log linear curve, and the death of public companies follows the curve pretty clearly. If you get to 50 years, 97% of companies will be dead by 50 years. So it's not that there aren't those that endure and kick along for a long time, but there's a statistical process that's going to get you. Of course, not everybody. How do you make sure you're one of the 3% or better yet, one of the 0.1% that lives an even longer time? I think I'm a bit philosophical about it. I think as a company, you represent a particular approach and you go for it. Sometimes you win and sometimes you lose. And you bring everything you can to the table. But if you're going to be in business for a very long time, you will have to have the capacity to reinvent yourself. None of the long-term players ever got that way by not reinventing. Intel started as a DRAM company. Intel was the first to productize the DRAM. It invented the microprocessor as a way to save money in terms of satisfying calculator vendors. But Andy Grove was smart enough to realize that he was on to something much bigger with microprocessors, and they pivoted all the focus of the company. And others pivoted to make the company focus more on things like data centers. And they tried a lot of other pivots that also didn't always work. But in the end, you're going to have to pivot. Microsoft is one of the most amazing companies in that regard. The pivots from Windows to Office, the pivots from the PC to the cloud, they had their failures too. Remember, they bought Nokia. They realized the future was data center and mobile. But what's tough in the big enterprise is to go all in. You can't win by playing defense. You can't win in a new market by just spending a lot of money and calling it a priority. You have to burn the boats because everybody else in that market, that is their number one job. It can't be your number 5 job. There's no point. This is where many companies make the mistake, and I've seen it time and time again. There needs to be no number 5 priority. I think this is what Steve Jobs was most genius at, saying, we have 200 good ideas, and these are great. And I want no one in this company spending any time on anything but the 3. He was so disciplined to force even a really pretty big company to focus very narrowly. That was something Andy Grove did with Intel. He realized, and this is about the time, this was shortly before I joined in the 90s, the PC is it. Not only microprocessors, but the PC. There's a PC revolution. This is our thing. We're doing this. After the Andy Grove era, Intel had a tendency to dabble in too many things. The top management had 10 priorities, the next level had 10 priorities. Pretty soon you've got hundreds of priorities floating around, and that's really a problem. I think another company has tremendous focus is TSMC. TSMC is a very straightforward business position, right? It's not trying to get into everything. It gets into everything by being the chip maker for everybody. Their focus is very simple. I will do whatever is necessary to make my customer successful. I know who my customer is, and I'm not going to muddy the waters. TSMC is not going to start making GPUs. They're amazing in their level of focus. But that means you have to have the discipline to let other companies win. Company is getting success. You don't suddenly, put on a black turtleneck and pretend you're Steve Jobs just because you're jealous. And so as a big enterprise with a lot of money, a lot of profits, it's very tempting to go spend money on everything. But the money isn't the problem. It's the focus.
Yeah. On the reverse side of things, one thing for large companies to stay relevant and can maintain their dominance. And on the other side, for startups to grow and manage growth and start to act larger companies, what challenges do you see there? Sometimes there are founders, maybe I count myself in that, cannot get out of the startup mode, right? So you want to be in everything all the time. So
I think that when you are 10 people, you have a stand-up call every single day at 7:30 a.m. and everybody knows what everybody else is doing. The coordination overhead is effectively zero. You need to write anything down? No. Can you change gears every day? If you want to. You're not going to confuse it. Can everybody understand why you're doing what you're doing? Yeah, if they can just hear you say it. You can even have, if they're upset about it, you can talk to them one-on-one. Communication problem whatsoever. 200 people. It's a little tough, but even 200 people. I probably knew 400 people at Intel that I knew personally. When I left Intel, my organization was 2,800 people. There's a lot of people I don't know in 5 countries.
Yeah.
And I was just one piece of an even bigger company. So it's the organizing that is the problem. The analogy I often use, kind of like climbing mountains. Mountaineering is a hobby of mine. I live here in Oregon. Climbing Mount Hood, which is a very conical shaped mountain. It's right outside my window here. It's beautiful. If you want to get to the top of the mountain, you just look up. And it's very clear if you want to get to the top, you just keep making sure you're hiking uphill. Then you get to the top. And the problem is going down. If I go down and I'm 3 degrees off on my way down and say there's a cloud and I can't see, I might be 10 miles from my car, right? Because the bottom of the mountain, the circumference of the bottom of the mountain is gigantic. The circumference at the top, I can walk around in 10 seconds. So this is just geometry, but if I make a little bit of a mistake going down, I way up. So companies are like that. This executive staff sitting on top of the mountain, they can all talk. If they don't understand the same direction and they start marching down their section of the mountain, different sides of this company are here. They're duplicating the same thing. They all heard the same message from the bottom. They didn't quite understand it, but this division started working on it and now they're competing. And then the people at the bottom, they don't even know what's on the other side of the mountain. It's a huge challenge. If you want to move beyond 200 people, you need to have very disciplined communications. You need to write down, you need to use things like OKR. Be specific, be open and direct. You got to enable people to ask their questions. You've got to, classical Intel culture back in the Andy Grove era, we had these business update meetings every quarter. One of the executive team would be in the room with the people. This wasn't a virtual thing. On site, might be 300 people in the room, some vice president, somebody pretty far up the chain would come and talk quite serious turkey. This is what happened last quarter. This is what's going on. They would take questions and it was very blunt. This is what's going on. You guys are investors. You guys are part of this company. That level of communication helped people really feel a sense of ownership and that they understood what was going on. They understood why we were doing what we're doing. That really helps you mobilize. OKRs help because you write down not just the deliverables, which is important. Is accountability is part of OKRs, but it's alignment even as much as it's accountability. I understand the big picture objective. I've written my results to align with that objective. I've discussed it with my management. I can hand that to my peer. It's like, this is my OKRs, what are your OKRs? People could use that as a brief. This is what I'm working on. And it's not an engineering indicator, but it's just an alignment vehicle and an accountability vehicle. This is kind of what I'd signed up for. Those kind of tools become really important Role clarity is really important. If you want to make something inefficient, have more people work on it. When you're giving action items at the end of a meeting, and this is hard to do, but every manager should know this, one name, never more than one name. The moment you put two names next to an action item, well, even before they get started, they got to talk about what they're going to do. And then before they report, think of just like the overhead. You just lost hours because they're, okay, I can't talk till Thursday. And I don't do anything on that action item until Thursday when I can talk to the other person that co-owns it with me. Maybe we're kind of dancing around who's really in charge. Maybe we fight like cats and dogs, but even worse, we avoid conflict. You confuse it all. But it's the manager, like, I don't even understand my organization all that well. So I'm just going to like, it vaguely feels like something Bob and Susie ought to do. So Bob and Susie, you go on, you figure it out. Well, you say you figure it out, you just wasted a ton of time. So if you're going to get up to be a big organization, you've got to master that. And here's the problem with innovation. Once I've got everybody nicely pigeonholed, the game changes. I'm disrupted. There's new technology. Now I've got a pretty good way of doing things. And it was so hard to put in place. The last thing I want to do is change it. Here's AI. Here comes a competitor. Here comes a new business initiative. What if the new business initiative doesn't fit the structure that I put in place? You've got to organize, reorganize, organize, reorganize. And you have to accept that is a huge part of what you do. The big enterprise, like an Intel or something like that, the problem is never not having enough technical people. The problem is never somebody doesn't know the answer to a technical problem. You've got boatloads of technical talent. The problem is routing the work in the right way. And so what that also tells you as an emerging enterprise, hire as few people as you can get away with. The more people, the more problems. I hate to say it that way, but the more you hire, and if people are hiring because they didn't make them feel important, and then people are like, oh, hey, I can't hire 50 people. Oh, but if I opened an office in India, I could hire 50 people. That's true. It's a lot cheaper to hire in India. But now you're coordinating across time zones. Now you added enormous communications overhead. There's time and a place to do it. But think very carefully before you complicate. If you're really successful, you might be having more money than is good for you. You want to really kill an emerging business? Give them a $600 million check. Enterprises make that mistake. Oh, this is really important. This is really exciting. I have billions of dollars to spend, so I'm going to give the GM $600 million. You can destroy that GM with $600 million. Gave him too much budget. And now he just kills himself. He gave him too much rope. Never underestimate how fewer is better, especially if you want to be nimble, especially if you want to be innovative. It's tough.
Yeah, that's great. That comes to my last question. I think you probably answered. You gave a lot of examples, or maybe a couple of other leadership lessons that you've learned working with a company like Intel, and how so for managing the teams better, maybe the people side of things, importance of culture, importance of training, and other such things.
All of those things are critical. I do believe deeply in the statement, culture eats strategy for breakfast. If your strategy and your culture are not compatible, you got a big problem. By the way, it's a lot easier to change your strategy than your culture. But invest in that culture. It's a beautiful thing. I do believe that my experience has showed me that leverage the talent of the people that you have. If you have a team, I don't care if it's 6 or 600, there's a lot of different capabilities there. They have a lot of different skills, a lot of different attitudes, and I mean diversity in a very broad sense. When I first became a business unit general manager, coming out of my technical space, as a technical guy, I was always like, the main thing is build the best product. And I'm like, sales, finance, yeah, you need that. But that's not the main thing. The main thing is the engineering, it's the product. A brilliant salesperson, a top tier 1% salesperson, oh my God, the genius that they can bring. It's incredible. And a finance person, I mean, you think finance, how big is that? I can reimagine my entire manufacturing business if I got really thoughtful about cost allocation. If you're in a foundry business, cost allocation is this huge thing. How you handle cost allocation actually kind of dictates. You got to have somebody who can really think very deeply about, because it turns out these business models are not as simple as they seem at first. So a genius finance person could really enable you in ways you maybe never understood. Or someone who's amazing at pricing. My experience was always just like, hey, value all these people, because your HR director is like, found someone, oh, well, we could redo it this way. And now you have this amazing luminary working for you or whatever. So utilize all the talent of the team, and don't ever be afraid to ask for what you really need. I think that's actually the hardest lesson for most people, to use a football analogy. It feels reasonable to ask the team to barge down the field so many yards. But the only thing that matters is whether you got them to the goal line or not.
Yeah.
Don't confuse what's reasonable with the goal line. The goal line is the goal line. Don't underestimate them. Always put the goal line where the goal line is and challenge them to and support them to meet it. But don't water the goal down. You got to put the goal. If the goal's too wimpy, then if we achieve the goal, but if the goal is ambitious and the goal is exciting, the goal will draw energy from everybody. Then we did something. If we can make it happen, then we did something. Now, people got to believe it's vaguely true, yes. But that goal setting, that's where the inspiration comes from. It's like, we can do this. And I can show you how that might add up and we could really do this. And then once people start to believe you a little bit, and then they make a little bit of progress, you can draw so much energy. You don't have to worry about budgeting. There'll be plenty of people fighting their way onto the project because of the inspiration.
Yeah. Zane, this was wonderful. Thank you for your time and all your knowledge, wisdom, experience. It was great talking to you. So thanks again and good luck with everything.
Likewise, Seth. Thanks for having me.
Thank you.